Hey TI tubers, hope you're up for some TI basic talk because, well, for the past month, I have been living and breathing TI basic game development. And, consequently, I've got a lot to say about how making games in TI basic can actually be kind of kick-ass. And how to optimize the crap out of them. When I say TI basic, I'm of course talking about the basic built into TI-99 ROM that you'll have on offer every time you start up a TI-99, in all its weird and problematic glory. Whatever you think of it today, TI Basic was the only option most folks had for writing a TI-99 program back in the day. For most of the millions of families with a TI-99, TI Basic was just what programming on a TI-99 was. And PEB cards and disk drives and memory expansions and even extended BASIC never entered the picture. And as much as we do like to complain about it today, TI Basic really did make meddling with TI sound and graphics pretty quick and easy. Right out of the box, you could type in call sound with a duration, a frequency, and a volume, and hear a sound. Then start putting those together to make a song. Which was pretty impressive for the 1979 to 81 years when it debuted. So now and again, I think it's important to get back to TI Basic and the old program recorder and see if we can't teach them some new tricks. For those first 2 years, they were the only tool set just about anybody had when early adopters took their first shot at writing a game for the TI-99. And I got to admit, what we got out of the TI Basic games of the system's heyday was often not what the programmer presumably hoped for. Because as natural as it was to end up at, I'm gonna make my very own Space Invaders for TI Basic. Well, not much good can come of that. And as natural as it was to end up at, I'm gonna make my very own Donkey Kong in TI Basic. Well, likewise, not much good can come of that. In TI Basic, you really do need a design that makes the most of what TI Basic can do, and sidesteps what it can't. And even more so, you need to design for what it can do quickly, and work around what it does really, really slowly. Like, draw graphics to screen. Drawing to screen being as slow as it is, most graphics tricks involve some serious smoke and mirrors, like creating animations by swapping palette colors for tiles already on screen, as you can see being done here. One of the best tricks in the TI Basic toolbox, that almost any good TI Basic game uses, at least some of the time. But in general, optimizing the crap out of Basic means keeping track of the time commands take, and using them with one eye always on the TI Basic time economy. A spreadsheet of TI Basic command execution times is always on hand when I'm working on my program, and that's linked in the description if you'd like to take a look. But even once you've figured out how you're going to get graphics on screen fast enough to make some kind of game, optimizing your code to use the memory you've got is a challenge all its own. And if you're writing a program as complex as the game I've been working on lately, well, that can mean writing some pretty crazy spaghetti code. But all that craziness is what I want to talk about today. The tricks used to make a TI Basic game that goes nuts pushing TI Basic as far as it'll go. So to prove something interesting can come out of that, here's a sneak preview of Hell's Halls from Run Through to Gameplay. So this is my shot at saying, you know what? TI Basic can do some pretty cool stuff as long as you code in the crazy way it needs you to. And at this point in history, I'm finding coding around TI Basic's limitations to be pretty entertaining. What used to be the frustration of TI Basic is now the fun of retro computing. Funny how that works, eh? But that fun aside, hopefully I can manage to make the resulting gameplay fun for players too. On the one hand, I'm looking to take TI Basic gaming to new heights here. But on the other hand, a really big motivation for taking a stab at extreme TI Basic optimization here is the fantastic TI Basic games I've played in recent years that I didn't get to learn from back in the day. So, we code on the shoulders of giants and all that. I'm getting inspiration from games like Lord of Spiders here that really gives you some impressive style and atmosphere and adventure in its short run. With the kind of multi-scene structure you didn't see in a TI Basic game back in the day. Or another great example being Grog here, which, great graphics aside, has got some really playable action gameplay. And finally, one more being Floraway, which just might be the best platformer ever designed for TI Basic. Maybe its only competition is Floraway 2. But in defense of the rest of us, there are good reasons that everybody else plugging away at our TI Basic programs back in the day never managed to make anything along those lines in our game endeavors. So, let's talk about why that is before we talk about how we're gonna get past it in the present. And the first challenge is of course just that, as you know, TI Basic is slow. So a lot of the strategy for designing a TI Basic game that doesn't seem slow is about using every pause to get things done and doing the hard work of drawing graphics behind the user's back. As you saw, the game I've been designing lately has a 45-second intro sequence. Why? Well, partly for flavor, but mainly to load character and color data in the background behind the user's back. Without the intro, it'd just sit there loading character patterns and color sets and tiles for 30 seconds on an empty screen. But with the intro, it's 45 seconds of something worthwhile instead. So a lot of TI Basic game design is about faking performance in that kind of way, just hiding the work being done behind the user's back. And you can see another example of that when my game loads its title, and then loads its game interface, where each time it draws 30 to 70 characters in a split second, which is just, well, not a thing TI Basic can do. And the trick there is the usual one. The characters were already drawn in the background with the transparent palette, and the reveal is just a palette switch using the call color command. Meaning, this is another case of hiding the work being done while delivering content. So TI Basic graphics are slow, yeah, but you can work around it. And basic graphics really can look great when you do. I've spent plenty of time on this channel showing off how good TI-99 Mode 1 backgrounds can look in Extended Basic. And TI Basic gives you 16 more patterns and 2 more palettes than XB does, which really is enough to paint something impressive. There's no shortage of colors or characters in Basic. It's just a matter of getting them on screen fast enough that it doesn't interfere with gameplay. Which is why my idea for a TI Basic game that works around that issue was a dungeon crawl, where the dungeon is generated and drawn as you explore. This works well for a few reasons, but the first one's the obvious one. If we drew every room on the dungeon level all at once, it'd take a long time. So, drawing it one room at a time deals with that, while also just making sense from a dungeon exploration standpoint. And doing it this way also helps limit how much memory the dungeon eats up, with the game only permanently storing in memory what it needs to procedurally generate walls and doors and objects in a way that lets every level be completed. And that memory economy is gonna be important, since memory economy really is the other half of the TI Basic game development challenge. On a computer where nearly everything lives in the 16K of RAM attached to the VDP, and that includes my program and all of its data. The upshot of which is, after making room for the variables the game needs to build a dungeon, just under 10K is left for my basic program code, including all the graphics. And consequently, out-of-memory errors showed up on the scene pretty early in development, with my program, well, maybe about half done. So about half of the development process has been optimizing code to make space for more of it. It's kind of like developing real estate in Manhattan. There isn't any space without things in it. There are just existing things that could be replaced with more things by rebuilding them differently. So, that's what I'm doing. And if I talk a lot about memory optimization, well, that's why. I at one point spent several hours rewriting a major subprogram, and managed to save a glorious 112 bytes in the process. And I'll admit, this all does raise the inevitable question, why on earth am I not just laying claim to vastly more memory by using Extended Basic with the 32K expansion, like any sensible person would? And yes, if I were using XB and the 32K, I'd have way more memory. And I'd have sprites and peeks and pokes and assembly subroutines and all the glorious stuff that makes XB so damn indispensable on the TI-99. But that's not what I'm interested in doing here. I'm writing a console basic cassette game, because I like a challenge, and because those were the first computing tools I ever had, which I'm sure was true for a lot of you folks likewise. Plus, I knew going into this that worthwhile things were possible in TI Basic, since I'd seen them done before. Still, the design I'm working with uses a totally unreasonable amount of data for a basic game, so I do need to find a way to load that in as compact a format as Basic will let me. And a huge amount of that data is the character patterns my program uses and loads during the intro. Over 1 kilobyte of them, and growing. That font I made is 30 patterns on its own, the eyes are 6, and so on. TI Basic loads patterns with the call char command, and that needs 2 inputs, a character number, and a hex string that represents the pattern. So, this is how my program would define its characters in a by-the-book way. There are a few reasons I'm not gonna do that, though, and they all come down to TI Basic tokenization. See, TI Basic doesn't store your program in memory as the source code you write it in. So, a compact program isn't one whose source code looks short or compact. It's one that's encoded into bite-sized TI Basic tokens in a compact way. Just to illustrate, here's a trick question. Which of these 2 silly programs is smaller? Which eats up less program memory? And the answer is naturally the first one is the smaller program. Takes up more space written out on a screen, but well, your TI-99 doesn't care about that. What matters is that randomize is a 1-byte token in memory, while the numeral 1 at the end of each call sound command is 3 bytes on its own. A byte for the data type, a byte for its length, and a byte for the number itself. So you kinda have to think past the words on the screen to what they mean in memory, since that's what you got to worry about at the end of the day. And that takes me back to why, when I look at those commands for defining my characters, I've got concerns. One is that while the call keyword is tokenized, any command after it isn't. So every time you write call char, that char part is effectively just a string eating up 6 bytes of memory. So instead of writing out 100 of those commands, the sensible thing is to have a subroutine with 1 call char command that loads my patterns from data statements. I figure I can still save a bit more memory on those data statements, though. Instead of listing each character number in my data, I'll put a character at the start of each character pattern whose ASCII value is the number of the character being defined. And my routine will grab that value from the string, saving me 5 bytes or so per pattern, which is a lot of data in a program that'll have, well, 100 or so patterns when I'm done with it. So my patterns still take up tons of program space, and that's somewhat inevitable, but a lot less than before, which means I can move on to another data type I need to worry about, and one I really want to get right: the game's music. There, my problem is that any TI Basic song is a potentially huge list of call sound commands, with an even huger number of arguments, which is how that tiny little list of 3 call sound commands I showed you earlier ends up consuming more memory than a way more complicated program. So the solution here is going to be some clever music math instead of hundreds of call sound commands. And I apologize because this is going to get a bit technical, but the way the story starts and ends is with me storing my music encoded in strings, in data statements that look like this. Just 13 bytes for my title jingle, for example. And the magic my music subprogram does is, it takes the ASCII value of each of those characters, then it multiplies that by 2 to get a frequency from 70 Hz to 254 Hz. Then it does one of 2 things with that. If the note's below 110 Hz, it can't be played on the PSG's tone generators, so I'm going to play it on the noise generator as periodic noise, while accompanying that with tone generator pitches in or near the second and third harmonic for that frequency. And that'll sound like this, for example. So that gives me one instrument to play, you might say, which can handle low pitches and gives me a creepy sound, which is going to be useful, presumably, in a dungeon crawl game. But still, not the sound I want for all my music all the time. So the rest of the time I've got a completely different approach to music, which gives me a different kind of sound for pitches at or above 110 Hz, and with more of a musical vibe. For those, what I'm going to do is play the bass frequency I'm working with, then accompany that with a frequency detuned a little upward. Then I'm going to mix that with a quieter tone near the third harmonic. And that sounds like this. In both cases, they've got a little attack and decay, too, where volume gets decremented pretty quickly after the initial attack, and that helps to make the sound more natural and more like a real instrument. But more importantly for present purposes, this is how, out of 13 bytes and in pure TI Basic, I get myself a jingle with some texture to it. If that jingle were written in a by-the-book way as a simple list of call sound commands, it'd be 39 call sound commands, coming in at just over 2 kilobytes of program data. So an absolutely huge amount of data. Meaning 13 bytes instead is a big win. Especially because now I can use my music subroutine to add easy, compact, incidental music for fanfares and such. Knowing any given music uses so little data, I can add it pretty much for free. Alright, so that's how I do 2 memory-hungry things in a way that works with the memory I got. I load my character patterns via string, while I distract the player with a flashy intro sequence, and then I play some music by likewise cramming all that data into tiny strings. The string's the thing, man. Now, my game uses tons of numeric dungeon data, so it's at least worth asking, is there a way to cram all that data into strings too? Especially given the way TI Basic stores that numeric data as memory-hungry 8-byte floats. There are no real integers in TI Basic. The number 1 saved to a numeric variable takes up 8 bytes, and the number 8,312,754.62 takes up 8 bytes. Sadly though, I need writing and accessing my dungeon data to be fast. So in TI Basic, there's just no compressing it. I can only imagine how commands like this one would run if I had to unpack that data for each of those variables first. There is one thing I've done to limit the memory those variables are eating up, though. I can't save on their data, but I can save on their names. A variable called, say, total is 5 characters long, and eats up those 5 bytes every single time it's referenced. And since the basic interpreter needs to read more data, long names are actually just a tiny bit slower. Just a millisecond or two, but, well, every second counts, right? So I'm not going to call my variables things like total and player HP and level. I'm going to call them things like Q and K and PY and PX. Because with some of those variables occurring 30 or 40 times in the program, even one more letter is claiming a meaningful chunk of memory. So, 1 or 2 character variables it is. The other much bigger thing I'm going to do to wedge this program into the not enough memory that I got is use a ton of subprograms. Anytime I can reuse a chunk of code, I'll reuse it by transferring control to a subprogram with GoSub. And you might look at those long lists of GoSubs and say, well, that's a lot of numbers. And you were just talking about how greedy numbers are. But the thing is, line numbers are one kind of number TI Basic does encode optimally, in just 2 bytes. So for TI Basic, line 1 passing control to line 2, or line 23,512 passing control to line 47,931 take the same small amount of program memory. You can pretty much be as wanton as you like with line numbers, with GoTos, and with GoSubs. And that's true from a performance standpoint too. You can transfer control with a GoSub and back 50 times in the time it takes to define a single character pattern. So, if you're transferring control to a subprogram that defines a pile of patterns, for example, well, the GoSub itself is barely worth thinking about. The upshot of all this is, in TI Basic, if you want to get the most out of the language, that really does mean enjoying your stay in spaghetti code hell, where GoSubs and GoTos make program source one big crazy spider web of code reuse, where subprograms are king, and subprograms call subprograms that call other subprograms, and where a lot of those subprograms have multiple entry points and multiple return conditions too. See, a TI Basic subprogram doesn't have any explicit beginning at all. So in my subprogram for handling player motion updates, for example, I can enter at one line if I want regular player motion and a sound effect, another if I want player motion without a sound effect, another if I don't need to update the tile the player's moving from, another if I don't need to update the position and motion variables for the player, and still another if I just want to write the player tile and nothing else. You just have to embrace the spaghetti code insanity and love it. Any line could go anywhere at any time. The possibilities are endless. And if you're trying to make the most of every byte in a huge program like I am, well, the opportunity to reuse code like crazy really is a blessing more than a curse. Even if you didn't want to design that way, TI Basic makes it pretty unavoidable, given the only thing TI Basic conditionals can do is transfer control to a new line. Every if ends in a GoTo, whether you like it or not, using the then token. So, you might as well learn to love it, and put on your go-go boots and go to wherever you please. Now at this point, after all this talk about optimizing the crap out of a TI Basic game, you're probably saying, alright, well, you've shown us the game and you've talked about it, so, well, give us the game already. And fair enough if so. Though alas, it isn't really finished yet. The engine, all the tools and subroutines the game needs are finished, and that's why I'm talking about that today. But the adventure content mostly is not done. So, it'll be just a little while longer before the full game is ready. If you really want to run the unfinished preview you've seen here on your TI-99, well, you can find that in the description as a WAV file, since this is a cassette game. Though honestly, I'd recommend just waiting for the finished product. You've seen what there is to see so far already in my quick preview. In the meantime, it's been fun to look at some of the finer details of building a TI Basic game in the present day. So, I hope some of you folks are as crazy as I am, and take an interest in TI Basic development likewise, where you really do need all your cunning to work with the tool set available, but where some pretty fantastic results are possible if you just learn to love the taste of spaghetti code. See you next time, folks.